Systems of equations and inequalities. A system of equations is a set of two linear equations. The equations can be written in either slope-intercept form or general form. A solution to a system of equations is the point that makes both equations true. On a graph, this is the point where the two lines intersect. Systems of equations have a single solution when the lines cross at one point. When the two lines are on top of each other, the system of equations has infinitely many solutions. If the lines are parallel and never intersect, then the system of equations has no solution. Systems of linear inequalities are a set of two or more inequalities. It is similar to systems of linear equations, but instead of equal signs, we have inequality signs. To solve systems of inequalities, we rewrite them so they are in slope-intercept form. For the first inequality, we need to subtract x on both sides. We can rewrite it as negative 4y is less than negative x plus 8. Now, we divide both sides by negative 4. This gives us y is greater than x over 4 minus 2. Remember that when we divide or multiply by a negative number, we must switch the inequality sign. For the second inequality, we subtract 3x on both sides. This results in y is greater than negative 3x plus 3. The next step is to determine if the lines should be dashed or solid. If the lines show less than or greater than, we will use a dashed line. If the signs show less than or equal to or greater than or equal to, we will use a solid line. Now that we have determined that, we can graph the lines. The first line has a y-intercept of negative 2 and a slope of 1/4. The line is dashed because it shows that y is greater than. In the second inequality, we have the y-intercept at 3 and the slope is negative 3. The line will also be dashed because it shows that y is greater than. Now, we need to test a point to know where we will shade. In the first inequality, if we substitute 0 in for x and 0 in for y, we will see that the inequality is true. 0 is greater than 0 minus 2. Because that statement is true, we will shade where the point is at. In this case, it is above the line. We will do the same for the second inequality. If we plug in 0 for x and 0 for y, we will see that the inequality is false. 0 is not greater than 0 plus 3. Because that statement is false, we will shade away from 0, 0. In this case, we are shading above the line. The solution is the area where the shading overlaps, which in this case is the green area. In this next example, we want to write inequalities that can be used to model the amount of cookies and chocolate Sally can purchase. We will have x representing cookies and y representing chocolate bars. We know that she can buy at most a total of 6 cookies and/or chocolate bars. We can write x plus y is less than or equal to 6. We also know cookies cost $1 and chocolate bars cost $2. She has at most $8 to spend. We can write 1x plus 2y is less than or equal to 8. The 1 in front of the x represents $1 for cookies, and the 2 in front of the y represents $2 for each chocolate bar. We want to put both inequalities in slope-intercept form. For the first inequality, we will subtract x on both sides, and that gives us y is less than or equal to negative x plus 6. In the second inequality, we will subtract x on both sides, giving us 2y is less than or equal to negative x plus 8. We divide 2 on both sides, and we get y is less than or equal to negative x over 2 plus 4. Now that we have both inequalities in slope-intercept form, we can graph them. For the first inequality, we have 6 is the y-intercept. The slope is -1, so the next point should be 1 down and 1 to the right. Now, we determine if it will be a dashed or solid line. Because it is less than or equal to, we will have a solid line. Next, we have to decide where to shade the line. Earlier, we mentioned plugging in 0, 0, but another way to shade is by looking at the sign. If y is less than or equal to, we will shade below the line. In the second inequality, we have 4 is the y-intercept. The slope is -½ so the next point is 1 down and 2 to the right. The line will be solid again. We will shade below the line because y is less than or equal to. Remember, the solution is where the two shaded areas overlap. However, because we cannot have a negative amount of cookies or chocolate bars, we only want the positive region.